Hello, everybody. Thanks again for joining us for today's maths session. We will be covering using Venn diagrams, and it will be led by Molly. I know a lot of you already know Molly from joining us from the past sessions. Molly is currently studying computer science and mathematics at the University of Bath, and she's delivered lots and lots of lessons with us so far. So for newcomers to this, this session will run for an hour, so we'll be ending at 1:15. Throughout the session, you are able to place any questions you may have within the chat in the Q&A section at the bottom of your screen. The structure of the session is normally 45 minutes of kind of Molly delivering a lesson, and kind of answering any questions that you guys may put in the chat as you guys go. And then the last 15 minutes is dedicated to questions. But yeah, as I said, feel free to put as many questions in the chat section in Q&A as we go along anyway. Molly, you can take it away when you're ready.
Cool. Okay. Hi, everybody. I'm Molly. You probably know me. So let's just get straight into it. So today's session is about using Venn diagrams. I think this will be a good session because I think I always like leading sessions on topics that I really struggled with, because I think that, I don't know, I wish I'd had something to explain them to me in a better way. And Venn diagrams are one that can be quite confusing. They've got a lot of confusing terminology sometimes and stuff. So we'll try to batter it all today and answer some quite difficult questions by the end of it. So let's get started. So a Venn diagram, you're probably all familiar with. Your kind of basic Venn diagram looks like this. And normally we label them as A and B. These A and B can change. So this can be children who study maths, children who study English, and then in the middle is both of those things. You're probably familiar with this. We can add more. We can add C, and then you've got all of these different sections. So this is B and C, but not A, and so on. It's about which circle they fall into. And it's a really great way of displaying information. So I'm just going to get rid of that one and just give you a little bit of terminology. So this whole space here, and I'm going to explain all of these with an example question in one moment. But the whole, what we call the domain, so the whole area that you're working within. So for example, in my thing of children who study maths, children who study English, the whole domain would be children, right? And they all either study both, just maths, just English, or neither. So this whole box is the whole domain. And what we call this is epsilon. It's like a backwards 3. It's a Greek letter. Mathematicians love using Greek letters for things because we've already used our own English letters for everything. So we throw some Greek letters in there. So this is an epsilon, and it just means the whole domain. And you'll see this in an example in a moment. I think I'll go through an example with this and then talk to you about some more terminology. So the example that I wanted to show you is this one. So there are lots of different types of questions when it comes to Venn diagrams. So there are some that are like, represent this information, a lot of probability questions, and some questions that you'll get where it's like shade this region. And those are the ones that I always struggled with, but I've got a really, really cool way of easily working that out. So here, these curly brackets, this means a set. So when it says curly brackets, factors of 140, it means the set of all the factors of 140. That's all that means. So 1, 2, 3 is a set. 10, 20, 30 is a set. Prime numbers is an infinite set, and so on. So what this means is that everything that's going to go within this box somewhere, whether it's in the circles or not, is a factor of 140. And then in here, we have some prime numbers. And in here, we have multiples of 5. And in the middle, we'll have prime numbers that are multiples of 5 and factors of 140. So the best way to do these is to list everything in your domain, so everything in epsilon. So let's do that. Let's list all of the factors of 140. So epsilon is going to be, right, 1, 2, 4. This is where I'll miss one now. 5, the 6 go into it. No, 7 does. Does 8 go into it? No. 9, no. 10 does. 11, no. 12, no. Okay, so then the rest, 14, 20. The way that I'm doing these, by the way, is I got up to here, and now I know that 10 times 14. We actually did this a little bit yesterday, if you're here, when we're listing factors. So 10 times 14 is 140, so now I'm working backwards. So 7 is multiplied by 20, so 20 is a factor. 5 is multiplied by 28, so that's a factor. 4 is multiplied by 35, so that's a factor. 2 is multiplied by 70, and 1 is multiplied by 140. So once you've like listed up to some that multiply, you can like count back up, if that makes sense. That's just a quick way of listing factors. Okay, I think the best thing to do with this really is to take each number one at a time. So let's look at 1. We know that everything now, so we can kind of ignore this. We know that these are all of our numbers, and we just place them one at a time. So 1 is not a prime number. It's not a multiple of 5. So it's not in A or B. So 1 goes on the outside. Okay. 2, that is a prime number, but it's not a multiple of 5. So that goes in just A. And we can do this for all of them. So 4 is not prime, not a multiple of 5. 5, that is a prime number, and it is a multiple of 5. So 5 goes here, because it's within the circle for A, and it's within the circle for B. 7 is prime, but not a multiple of 5. 10 is a multiple of 5, but not prime. And so on and so forth. So I'll fill in the others, hoping that I get this right. 70, 140. Do correct me if you think any of those are wrong, or just shout if you want me to go through any. I didn't want to make it too slow. Go through loads of them. Oh, someone's asked, what would a Venn diagram with 4 groups look like? That's a good question. I've never really thought about that. It would look like this. Okay, I'm probably going to get this wrong because you've got to make sure that all of the bits that overlap are right. So it would look like this. Basically, you've got to make sure that there's a group for all of them, just 2 of them, just 3 of them, just 1 of them. So that's actually very difficult to do. So don't take my word for it that it's that. I think it is. Because like this would be all of them. And so but I don't think you would have to do that. I think it only ever goes up to 3. Someone has said, oh my gosh, I've lost where I was writing. Oh no, I found it. Someone said, why are there only 2 circles? That's because we don't have another circle for factors of 140. That's our domain, right? That's just the numbers that we're working with. So we don't need another circle for that. And someone said, what does the word epsilon mean? It's just a letter, like how we have A and B. This one's just called epsilon. And it just means the symbol represents is the whole set. So the numbers that you're putting in here. Okay, cool. So hopefully that makes sense, how we sorted that information. Now I want to talk a little bit about probabilities. So these are some quite common questions. And I'm going to, try to talk about them and draw them out for you now. So we write probabilities using the letter P. So let me just draw this. This is our standard kind of diagram. Now the notation that we use is this. And what this means is probability of A. So we do P and then brackets, and then the stuff in the brackets is probability of that. So the probability of A is what's in here, right? So if we had, let's do it with some numbers. Let's just choose some random numbers. So what I'm doing here is different from before. I'm saying how many objects are in each of the sections now. I'm not actually listing all of the objects. So let's say there are 5 things on the outside. There are 3 things in here, 1 thing here, and 2 things in here. The probability of A is this bit, right? Everything that's in the circle for A. So that's 3 plus 1. So there's 4 things in A. One of them also happens to be in B, but it's in A, it's in that circle. And how many things are there here total? Well, you just add all of these together. That's 11. So the probability of A is 4/11. So the probability that if we grab a random one of these, it's got a 4 out of 11 chance of being in A. Exactly the same thing with the probability of B. That's just going to be everything in here. So the probability of B is 3 out of 11. Hopefully that makes sense. And because things can be in both of these probabilities don't have to add up to 1. Because something can be in A, they're not mutually exclusive. Something can be in A and be in B. So that's those ones, and hopefully that makes sense. Then we've got some fancier things. We've got, just draw this out again, probability of not A. In fact, I'm going to stop writing probability for now. I'm just going to write what the things are, and then probability will come later. So not A. When you put a little dash by it, we either call this A prime or A dash. What it means is not A. And now the probability of A and the probability of not A do have to add up to 1. So if we look here, our probability of A was 4, 4/11. The probability of not being A is everything outside of this circle, so 7/11. Because those are mutually exclusive. You either have to be A or not A. You can't be some weird in the middle. That's not how life works. Well, it's not how maths works anyway. So if we want to show this shaded, it's everything not in this. It's everything not in that circle for A. Hopefully that makes sense. Oh, a couple of people have said, what does mutually exclusive mean? That's a good question. Mutually exclusive means that you can only be one thing or the other. For example, a number being odd or even, they're mutually exclusive. A number can't be odd and even. Does that make sense? I hope so. So being A and not A are mutually exclusive, because if you're not A, you're in not. Does that make sense? You either have to be in the circle or outside. You can't be on the boundary. You can't be somewhere else. You're either in the circle or you're out of the circle. That's what mutually exclusive means. It's one or the other. So that's what not A means. Now we'll do a couple more. And don't worry if you're not following at the moment. Hopefully you'll get it as I do some more. This always happens with these sessions. At the beginning, I have to get a lot of content out, so it can be quite confusing and overwhelming. But then we'll do loads of questions, and hopefully by sticking at it and working them through, everything will make sense. So now we've got some scarier looking notation. We've got these lovely things. I'll do, yeah. What am I going to do? Colours, okay. Horrible, right? This looks like an N. It's not an N. An N would be like this, right? This is just a kind of, it's just a curve. And this means A intersection B. Loads of words for this. Intersection. The most common ones that I'll use are intersection and. So what this means is it's A and B. So that's this bit here. If you're in that middle bit, you're A and B. And the way I always remember it is this kind of reads as A and B, right? If you're kind of writing, I don't know, in a slang way, you know, like salt and pepper was a weird example, A and B. I don't know, that's how I remember it. So I remember that one's and, so if you're A and B, you're in the middle. Fish and chips, yeah, exactly. Nice. Someone just asked, that's a really interesting question, who invented the Venn diagram? I think it was, oh, I can't remember his name. Okay, I'll come back to you on that one. Okay, so that's what that one means. I hope that makes sense. And then we've got a really similar one, like this. Again, this isn't a U, it's like the upside down of the other one, it's just a curve. And this means A union B. This is like or, so A or B. So like one or the other, or both, doesn't matter. It's an inclusive or, so it means A, B, or both of them, whatever. So it's all of this bit. So I'm so confused with salt and pepper and A and B. That's just me being silly the way that I remember, because these two are quite easy to get confused between. I'm just saying the way that I remember it is thinking A and B, A and B. That's how I remember that one. So yeah, this one is the union of them. So A and B together. And we can use these to shade lots of weird and wonderful things on the diagram. So hopefully this makes sense. So we can have some questions, for example, that say, let's have a look at this. Let's say we have a question that says shade this. So this is what I mean, you can have some weird, horrible combinations, right? So shade, and what this means is not A or B. So we can first of all think about, what does this mean? Well, this means all of this space, right? That we've been through. And not is everything else inside the box that's not currently shaded. So this whole thing is this. Because if you're not A and you're not B, you're in the outside of it. So whenever you have to shade not, think about what it would be and then shade everything else inside the box. Again, we're going to do a lot of questions, so I hope it will eventually make sense. So here's one that I wanted to have a look at, I think. Yeah, okay. Loads of ones like this, which shade the region that represents blah, blah, blah. And they're really hard to think about. So shade the region that represents not A and not B. So there's no way, well, maybe you can. I definitely couldn't look at this and do it straight away. But I've got a really nice trick to show you. So we're going to first of all look at not A. We're just going to look at each little part. So not A, we know is everything that, so A would be everything in the circle, so not A is everything outside the circle, right? So it's this here. So we're going to shade that in one colour. And not B is everything outside of this circle of B, right? So we'll shade that in another colour. So think about these as two distinct things. All the green there is not A, and all the blue there is not B. Hopefully that bit makes sense. And then we're going to think about, because this is intersection, right? This is and intersection. We want to think about where these lines intersect. So what we do is we shade to do the whole thing. We think about where the blue and the green intersect, because we want it to be green and blue. So where they intersect is all of this outside bit here. That's really bad shading, but I hope you get the idea. Hopefully that makes some sort of sense. Yeah, this is actually the same as the other one. That's some interesting laws of, I'd say this is year 10, year 11. I can't remember. Someone's asked that. Hopefully this makes sense. Okay. I'm going to try some more just because I think this isn't the page that I want. Because I think if you're confused, then hopefully by doing some more, it will make sense. For example, this. So shade the region that represents not A or B. You don't have to understand what that means. You know, you don't have to know at the moment. We're just going to do the same thing. We're going to think, right, what's not A? It's everything that's not in A. This is really hard to shade. Sorry, this is really, really bad. And then we're going to think about B. What's everything that's in B? It's this. And then because this time, so if this was an intersection, we'd have just this little crescent here, right? Because that's where those intersect. But we have a union, which means that it's everything that we've shaded. So our actual solution, I'll maybe do this on a separate one to kind of show you what I mean. Oh, this was a bad idea. Hang on. Oh no, what have I done? Okay, I just want to grab this again to do it on a separate one so that there's not too much color on one thing. So it's everything that we've shaded, green or blue or both. So it's this bit's shaded, here, this bit's shaded. So that's our answer, that pink. I hope that makes sense. So because it's the union, it's this green as well as all of the blue. Okay, cool. Some people have said that that makes sense, which is good. Like I said, I'll do a few more. Hopefully, I remember when I was studying this, like I said, I really struggled with this. But suddenly, at one point, after doing loads and loads of questions, at some point it clicked. So we'll have a go at a few more and hopefully that happens. Let's do this one. So shade the region that represents A and not B. So maybe you can immediately, sometimes with these, and especially if you get used to doing loads of them, you can think, oh, well, what part of this diagram is A, but it's not B? So if you can just think of that and do it straight away, great. But I always find it easier to kind of think about it in a foolproof way. So let's think, what's A? That's everything inside this circle. Lovely. So basically when I'm circling things to do with A, I imagine that that B circle is not there. Imagine it's completely not there. I'm just shading A. And now I'm thinking about B, I'm imagining that that A is not there at all. Not B is everything outside of the circle B. So I'm ignoring A, ignoring the fact that I'm going through it. I'm just shading here. Right? Now we've got to look at the symbol. So here's where the lines because it's an intersect, it's where our lines intersect. That's why I always do some lines going that way, some going that way, so that I can see where they cross. Because it's an intersect, here it is, it's this little crescent bit of A. So that, if I pop this on here again, that's our solution, is just this bit of A. I think a few of you got that as well. Oh, someone's just said, shouldn't the outside be green? No, because so green is just A. So it's just everything that's in A. Okay, I'll do one more and then I'll move on to a different type, but I can always come back to these at the end. So just let me know. Oh, it's already the different type. What I want. Okay, I guess I'll go through. I'm going to go through one like this. This is actually a slightly simpler one. because we can think about this straight away, but hopefully this will kind of prove it to you. So shade the region that represents A intersection B. Now we know what this is, right? Because we know what this is. We know it's the middle bit. If you're in A and you're in B, you're in the middle bit. Let's think about it in this way, just to prove to you that this works. Right, when are you in A? You're in A when you're in this circle. When are you in B? You're in B when you're in this circle. So when are you in A and B? Well, where you're both green and blue, here in the middle. So that's why that one is the way it is. Hopefully that makes sense. Someone's just asked for another union one, so I'll happily do that. I'll do this other kind of simple union one. Someone's also asked what the P means. Probability. So you can basically ignore it when you're shading. It just means we're shading probability of, so here the probability of A and B is whatever number is in here out of however many they are. That's what it really means, but you don't really need the probability. We will in a minute if we're dealing with actual numbers, but in terms of shading, don't worry about it. Okay, so let's have a look here. Now this is going to start in exactly the same way as that previous one. I'm actually going to have, no, I'm not going to be able to fit both on the screen, but you'll see it's exactly the same. So when are we in A? We're in A when we're here. When are we in B? We're in B when we're in this circle, right? That's just, I'm kind of ignoring the other circle, just thinking, when am I in A? I'm in A when I'm here. When am I in B? I'm in B when I'm here. So I've just shaded those. And now what we've got to think about, I'm just going to get another copy of this so that I don't clog up that one with too much colour. So now I think, what symbol have I got here? I've got a union. So it's anywhere where there's any colour. We don't care where they cross over here. We just any region where we've drawn any colour, because it's green or blue, or both, we don't care. And that's the whole of this bit, which we know is what union means, A union B. It's the whole of this bit. So hopefully that makes sense. Someone said, doesn't that mean intersect? No, this one's union. So this means anything that's in A or anything that's in B, the upside down one, the N. There are a few more questions, but I'm going to move on to a different type. But just shoot them in the Q&A or in the chat and I'll pick them up at the end. Like I'll do some harder questions and stuff at the end if I get a chance. Okay, so I want to think about now a couple of different types of questions. So, for example, this one. So I'm going to think about some filling in information and some probability. These ones are hopefully a bit easier. I think they can just be a bit tricky in the way that they're worded and thinking about where things are going to go. So when we're reading questions like this, it's important to approach them in the same way and think about things as you're going along. So for example, out of 50 people surveyed, that means we know that our epsilon is 50, right? So the total, basically, we're going to have to fill in a number here, a number here, a number here, and a number here. That's all the information that we want to put on this. And we know that the sum of all of these numbers has to be equal to 50. Now, 30 have a brother. That means that the sum, in fact, why don't I put some letters in here? We'll call this B, we'll call this S, we'll call this X, and let's call this N for neither. So 30 have a brother. That means B plus X is 30, right? Everything in this circle. But we don't know how many is actually in the middle here, so we can't fill anything in just yet. If 25 have a sister, that means S plus X is 25. And that's because everything in this circle is 25. Again, we don't actually know how many have both yet. And we know that 6 have neither a brother or a sister. So we can fill this number in here, n, straight away. Let me do it in a different colour. That's 6. I hope that makes sense. So up here, when I said that E equals 50, that's the same thing as saying B plus X plus S plus N equals 50, right? All of the numbers that we're going to fill in, all of those squares that I drew at the beginning. Oh, someone said, what's a universal set? That's the other name for this here. So if you ever see the universal set is 50, that's epsilon. That just means everything that's in this. Okay, so now let's think about what else we have. Well, because there's 50, but 6 of them don't have either, the rest have to be in these 3. So we know that B plus X plus S, so everything here is equal to 44. Because 6 are here, so the rest have to be 44 to bring it up to 50. Okay, now it's where we have to get a bit sneaky, and it's usually the same trick or something really, really similar. Here's what we're going to think about. I'm going to look at this that we've written down and this that we've written down. Okay, so let's think about these pieces of information together. If the total in this circle here is 30 and the total in all of them is 44, this bit here has to be 14. Does that make sense? If you want to think about it purely algebraically, we're kind of taking this equation away from this one. Kind of thinking this B plus X bit is 30. So we can replace this by 30 and get that S is 14. But I think a nicer way to think about it is in terms of the Venn diagram. So everything in this brother circle here is 30. And everything in this whole bit of the 2 circles has to be 44. So it's kind of like thinking, if we just write 30 like this in that whole circle, then this bit here with this, that has to be 14. Someone said, how is it 44? 50 minus 6. So the whole of the rectangle has to be 50, but 6 of them have gone here, so these 3 then have to be 44. So hopefully me writing the big 30 here, I hope that kind of helps a little bit. So yeah, B plus X is 30, so 30 people have a brother, so this whole circle is 30. And 44 people have a brother or sister. So this whole bit is 44. So if this circle is taken up with 30, this little crescent bit here of the sister, this has to be 14 to make it up to 44. Hopefully that makes sense. Oh, I just want to get rid of that 30 actually, here we go. If you're not following, don't worry. I'm going to finish this question and I'm going to do a couple of others. So maybe it'll make sense the next time I go through it. And now it's quite easy, I think, to finish the rest of this. So let's look here at this one. 25 have a sister. So that means this whole circle is equal to 25. So if 14 of them are in this bit of the circle, this bit of the circle must be 11. Right? That means everything in this circle then is 25. And now we'll use this bit. Everything in this circle has to be 30 because 30 people have a brother. So this bit here is going to have to be equal to 19. And there we go, we've filled in all the information. Some people don't quite get this. I'm going to hopefully, I don't want to over-explain this one too much because maybe it's just this example. So I'm going to go over some different examples and see with that. The part B of this might be about, oh no, it's not okay. Okay, I'm going to do here. This is a really, really similar question. So I'm going to show you that we apply the exact same techniques here. And this time, let me know if this makes it worse. I'm going to try not labeling them with letters. I'll try that. It just means that you have to listen to what I'm saying a bit more. And I know that that can be really hard. So let me know if you want me to go back to writing things down, but I'll try it without, because that might be a bit confusing. So we've just got to keep this information out of our head. So 40 students were surveyed. That means This whole thing here is 40. All of these numbers that we put in, they've got to add up to 40. 20 have visited France. So in this circle, there's 20. 15 have visited Spain. So there's 15 in this circle. But again, we don't know how many are in the middle. 10 have visited both France and Spain. This one I think is a little easier. 10 have visited both France and Spain. We can put this straight in. There it is. Okay, that's what that means. If 10 people have visited both France and Spain, 10 people are in this middle intersection here. Okay, now let's read back up and see what we've got. 15 people have visited Spain. That means that the total number of people in this circle has to be 15. So 5 people must just have visited Spain, because that means that the total number in this circle is 15. And the total number in this circle has to be 20, because 20 people visited France. So this has to be 10. So what this means is that of the 20 people who visited France, 10 of them also visited Spain. And of the 15 people who visited Spain, 10 of them also visited France. That's what this means. Okay, I think people are finding this example a bit easier, which is good. Maybe I should have started with this, sorry. The only thing that we now have to fill in is this outside bit here. And this is everyone else who was surveyed, who didn't go to either. So we know that the total is 40. Well, the number of people that we have here is 25. So there's got to be 15 other people, make it up to 40, that haven't been to either country. Hope that makes sense. Venn diagrams are quite a difficult concept. Get over. Okay, that might be quite a hard one. Oh gosh. Okay, you know what? I think this could actually be okay. Famous last words, right? Right, God, I used to hate questions like this because there's so many words. They're okay, you go through them line by line, you fill in what you know. But I hate when examiners do this. They just give you so many words, and it's really off-putting, I think. If you're in an exam and you're already trying to focus and you have so many words to read. I don't know, maybe that's just me. So we're just going to go through really slowly, line by line, and think about what we know. So we've asked 50 people which drinks they liked from tea, coffee, and milk. So this is a Venn diagram that looks like this. Okay, and this is, let's do tea, coffee, milk. So already it's looking a bit better. We've got some diagrams going on. It's not just words. Now, this is important. All 50 people like at least one of the drinks. That's good. It means that there's no outside box for us to actually do. They're all going to fit into one of the circles. Nobody likes none of them, right? So nobody goes outside. 19 people like all 3 drinks. We can pop that there, right? This is the intersection. 19 people like all 3 is. It's in the tea circle, it's in the coffee circle, it's in the milk circle. So 19 people like all 3. 16 people like tea and coffee, but don't like milk. So that's going to go here. And that's because this is in the tea circle and the coffee circle, but not the milk circle. That's what these 3 bits are on a 3-part Venn diagram. They're like 2, but not only 2 of the options, right? 21 people like coffee and milk. Okay, so I think that means everything in these 2 circles. That's quite vaguely worded, actually. I think that could mean everything in these 2 circles. So we can't fill anything in yet. 24 people like tea and milk. So I think these two circles is 24. 40 people like coffee. So this whole circle here has to add up to 40. And one person likes only milk. So we put a 1 here because that's only in the milk circle. It's not in the coffee circle or the tea circle. Someone said, can you do this question without drawing a Venn diagram? That's really interesting. Probably. It would just be very difficult, I think, because you need a way of, because we're going to need a way of visualizing the information and filling in the gaps of what we know. So, yeah, I'm not 100% sure. You probably could, but you'd end up doing really similar techniques anyway. I think it would just be more information to hold in your head. So let's cross off, this is what I find really useful to do. Let's cross off the things that we've definitely used and won't be coming back to because we've written it down. So we've used that 19 people like all 3 drinks. We've used this one and we've used this one. So I'm trying to work this out along with you guys. So bear with if I pause. Okay, so let's think here. I might have to introduce some algebra. I don't want to do that because I think it makes it more confusing. So we know that 21 people like coffee and milk. So, oh, maybe that does go in the, oh no. Oh, I'm sorry. Okay. 21 people like coffee and milk means there are 21 people in this gap here, right? Because this is the, if we ignore the T circle for a minute, it's really hard to do, but pretend that that T circle does not exist. So imagine we've just got these 2 circles here. Then there are 21 in this intersection, right? 21 people like coffee and milk. So that means that there must be 2 here because we've already got 19 people in this intersection because we know that they like tea as well. So there've got to be 2 more here so that this whole intersection is 21. That's the hardest step that we've done so far. So I hope that one makes sense. I think it really helps if we ignore the T circle. I'm going to do a similar thing with the next one. 24 people like tea and milk. So now we're going to ignore the coffee circle. We don't care about that. If we just imagine that we have the tea and the milk circles, 24 people like both. So this bit has to be 24. Well, we've already got 19 people in there. So we just need to pop 5 more in. I hope this is making sense. So we've used that one. And now we can use this one. 40 people like coffee. So again, now we kind of ignore the tea and the milk circles. We're just thinking about the coffee circle now. Coffee circle sounds like a middle-aged woman's get together, doesn't it? Now we're just thinking about the coffee circle, which is here. So 40 people like coffee, so there has to be 40 people in total in here. Well, let's see, how many have we already got in here? We've got 37, right? That's just these 3 numbers added. So we've just got to pop 3 more people. It's like, you can imagine it as a group of middle-aged women meeting, right? There's already 37 of them here. There's got to be 40 in this circle in total, so we've got to give them 3 more to bring it up to that total. So we've used this piece of information. And now all we've got to fill in is this. Well, we know that there were 50 people in total, and they all like at least 1. So every single number here has to add up to 50. So let's see what we've got so far. Gosh, mental maths. I think there are 46. So 6, 7, 46. So that means there've got to be 4 in this little circle. And now we've fitted every single person. You can literally imagine it as 3 kind of rings on the ground. And every person who was interviewed fits into one of these boxes. So they either like just tea or just milk or just coffee, or they like all 3. There's 19 of them there in the middle, knowing that they like all 3 drinks. Or they only like 2 of them. And so on. Please shout if that didn't make sense. So that's how we fill in this Venn diagram. Now we can answer any probability questions really easily. So let's think about this. We want to do, so we've selected one person. So we draw a name out of a hat. what's the probability that this person likes tea? Well, who here likes tea? Let's think about that. Everyone in this ring. Again, it does help to imagine it as 3 rings on the ground and people are actually standing in them. And everyone who's standing in this ring likes tea. So how many people are in here? Well, you just add up all of these numbers. It doesn't matter now whether they like milk as well or whether they like coffee as well. We don't care about that. We're only thinking about the tea circle. So let's add up all of the numbers that are in here, and that's going to give us 44. So it's 44 women. I'm just calling them middle-aged women because I think it makes it easier to imagine them standing there. 44 of these women out of the 50 that are standing there total like tea. And there's your probability. That's all it is the number that are in that group out of the total. So if we pick a woman at random, there's a 44 out of 50 chance that she's going to like tea. And we can simplify this as well. We like simplifying fractions, right? We just find something that divides both the top and the bottom. So here we can divide the top and the bottom by 2. And there it is. So that's a really difficult question because you've got to place everything in this Venn diagram and then you've got to work out a probability from it. I think that would be a 4-mark question, I think it said. Yeah, about a 4-mark question. So we've got 15 minutes left. So if anybody has any questions, whack them on the Q&A now or the chat, and I'll answer them now. Okay, a lot of people are just asking for, yeah, another one like this, some harder questions, cool. So I'll do another wordy question like this, I think. Just check. Someone said how many marks? Roughly about 4 for this. Okay. I'm going to do another one like this. Keep asking your questions, and once I've done another word question, I'll come back and answer that. So let's have a look at this one. We've got another three-part thing. So, okay. So Sammy asked 60 people which sports they liked from rugby, football, and cricket. So we have 3 here. And we've got football, rugby, and cricket. Now, it doesn't say that they all like one of them. And in fact, our question, if you look at the end, is how many people liked none of them? So that means that we're going to actually have this outside area. So it's not too much harder. We've just got one extra kind of number to fill in, basically. And we're going to do exactly what we did before and just look through one at a time. So 8 people like all 3 sports. There they are. Those rugby, football, cricket lads who like all 3 sports. There they are in the middle, in all 3 circles. 17 people like rugby and football. So what that means is that there are 17 people. Now be careful, we don't just want to write 17 straight in here. Because if we ignore, really good thing to do is to think about the 2 that you're thinking about and ignore the other one. Because they haven't told us anything about cricket in here. So if we ignore the cricket circle and just think about these 2, there are 17 people who like rugby and football. So the total in this intersection here has to be 17, which means that this bit has to be 9, because those 2 numbers in there have to add up to 17, so there's 17 in that intersection. 13 people like football and cricket. So we ignore the rugby circle and think here, this is going to be 13. So we've got to put a 5 there to make it add up. and 19 people like rugby and cricket. So again, it's exactly the same. We're going to ignore the football one and just think about these two circles. There are 19 people who like both rugby and cricket. So this is going to be 11. So this is why you wouldn't really want to do this without a Venn diagram, because this makes it so clear who belongs in which group. Okay, 35 people like football. Right, now we're only thinking about football. We're only thinking about football. So we don't care about these other two circles right now. We're just thinking about this circle. And we know that 35 people like it. So all the numbers in here have to add up to 35. So if we're getting a gathering of all the people here who like football, this many of them, so 23. I'm just checking I did the maths right. I don't think I did. 22. Math student. 22 of them are already there, but we know there's got to be 35 in total. So there's 13 more of them coming along. 27 people like cricket. So again, ignore the other circles. Just think about this one. We want 27 here in total. We've already got 24. So 3 more have to join. And 30 people like rugby. So again, we're going to ignore the other circles. Just think about this one. There are 28 people already there. So there are 2 there. So now all that is remained is who's on the outside. And this is actually our question. How many people like neither rugby or football or cricket? So there were 60 people asked in total. Let's see how many we've already placed. So we just add all of these numbers together. And that's going to give us 53. I think that's what we're going with. Correct me if I'm wrong. So there are 53 already placed. So the remaining 7, there's nowhere else for them to go. They're the ones on the outside. So the answer to this question is 7. 7 people don't like any of those sports. I'm just going to make up one tiny little question for this just to demonstrate probability, and then I'll answer some more questions. So what is the probability that a randomly selected person from the group likes, let's say, football and cricket, but not rugby? Gosh, I didn't put a question mark on my question. So we've just got to think about what this region is. So if you get confused, you can do the shading method, but I think this one's okay. So they like football and cricket, so they're somewhere in here, but they don't like rugby, so they're not in that bit. So it's just this section here, right? Just this bit. The people standing in this little section, they're in the football circle, they're in the cricket circle, but they're not in the rugby circle. So how many is that? That's 5. Out of how many? The 60 that are here total. And we can simplify that. That's just a quick little other demonstration. Oh, apparently I added up the numbers wrong. You know what? Let's get out the trusty calculator. I tried to add them too quickly to move on, like a silly bean. Right, 13 plus 9 plus 8 plus 5 plus 11 plus 2 plus 3 is 51. Wow, we don't have to talk about that. There you go, easy fix. And that's why you should check your answers. Haha, deliberate. Okay, yeah, it is 9. Loads of people got that as well, so well done, and thank you for pointing that out. Okay, I'm going to do, someone's asked to do a harder shading question that involves union. So that's what I'm going to do now. So let's do, this is a very long thing. So we've got A and B, right. And our question is going to be shade. Okay, we're going to shade Not A, union B. Is that? Oh, I'll tell you what, I'll do this one and then I'll do one with 3. Risky business, but I'm going to do it anyway. So let's just have a look at this. As a little refresher, I know we've only got 5 minutes, but so not A. That means everything that's not in A. So that's here. So remember, when we're shading this, we ignore B. We're just thinking about the A circle and we shade everything that's not in it. Then we think about B. Now we shade everything that's in B. And now because it's a union, the bit that we want is anything that's shaded. Anything at all, no matter what colour it's shaded. So what we do is, I'll just draw, excuse me, another mini one here. So then to do this whole thing, we look over here and we just shade everything that's shaded at all. Any colour, we don't care what. And that's this. So hopefully that makes sense. And I'll do one with 3 just to get that in there. Okay, let's do one. This could go, this could be interesting, but we're going to do it. Oh gosh, that's a thick pen. Right. Okay. Someone's asked how many marks would that be? I think it would be about 2 or 3 marks. So let's do this. Let's go crazy, right? A, B, and C. And we want to shade. Okay. Not A. Oh gosh, this is going to be such a, okay. Not A intersection B, union C. Okay, so this is a really difficult one. Okay. What I'm going to do is split this up into 2 bits. Notice how this bit's in brackets, right? We're going to do this bit first. So we're going to split this up. Also, someone's just said that they found them tricky, but now they get the questions, and that makes me so happy. So let's just think about this A and B bit. So not A, currently I'm just looking at this bit and just looking down here. So not A, there it is. Intersection B, so what does B look like? It looks like this. So what's the intersection? It's where they cross, where they're both shaded. So that's here. So now we're going to translate that onto this one. So not A intersection B, we know looks like this. Right? Now, let's think about C. So we can kind of think about this now as kind of like a 2-part one. We've circled the bit that we wanted. Now we want union C. So what does C look like? Looks like this. Now that's union, so it's anything that's been shaded whatsoever. So let's just redraw it out just to make it all nice and neat. Tell you what, I'm getting good at drawing circles. Just want to point that out. Oh gosh, she says really messing up the circle. So the whole answer, I'll do it in purple, is just anything that's been shaded at all here, which is this. Oh, sorry, and this bit. There you go. So hopefully that makes some sense. Someone said, when does the session end? Right about now. And I've actually finished on time for once. Shocking.
Indeed, indeed. Lovely session there, Molly. Thank you very much. And well done, guys, for the amount of questions that came through. I see that we had some questions relating to what we're going to be studying next and when the next math session is. If you haven't already signed up to receive our weekly emails from the online school, please do so, because every week you'll receive an email that gives you basically a timetable of of all the sessions that will be delivered during that week. So that will help you kind of plan ahead better. Also, for those that don't know, every session is recorded, so you will be able to catch this wonderful session delivered by Molly online on our YouTube channel, and that should be up by tomorrow. So yes, thank you very much. Thanks, Molly, and thank you everyone for joining us. Have a lovely day, guys. Goodbye.
Thank you, guys.